Here we're being asked to use the graph of f of x equals absolute value of x to obtain the graph of g of x equals absolute value of x plus 3. So first off, then we need to know what the graph of f of x equals absolute value of x looks like. And this is one of what are called the common functions. So we should have ideally some level of familiarity with these. And if not, we can at least generate a graph of them quickly using a table of values by plugging in a -2, a -1, 0, 1, and 2 in for x. So here we're using f of x equals absolute value of x. This is the graph we're supposed to start with. So the absolute value of -2 is 2, absolute value of -1 is 1, absolute value of 0 is 0, absolute value of 1 is 1, and absolute value of 2 is 2. So let's go ahead and plot these points. We have -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. So we see in our absolute value function here we get this V shape. Okay, then the whole objective here is to be able to look at this function g of x and identify, just by looking at its equation, how it's different from the graph of f of x. F of x again being that common or parent function, just absolute value of x. So what does the plus 3 do to that? And in this situation, when we add or subtract a number on the end there outside of the rest of the function, this is going to generate a vertical shift. And so that by adding 3, this is going to be a shift up 3 from the graph of f of x equals absolute value of x. Basically, the absolute value of x was those were our y coordinates. If I look over here in my table where I have that absolute value of x, that's in my y column. And by adding 3 to that, I'm adding 3 to each of the old y coordinates. And so that's just going to move the whole thing up 3. So if I were to make a new table with g of x, the only thing that would be different, because it would start with the absolute value of x the same as f of x did, the only thing that would be different was then that I'd be adding 3 after that. So I would just take each of these numbers in this y column and add 3. Okay, visually, we're just going to take each of these points on f of x and move them up 3. So I'm just going to go up 1, 2, 3 units. I get a new point there. Up 1, 2, 3 here. Up 1, 2, 3. Up 3. And up 3. So to graph using transformations, we have to know a little bit at least about what these common functions look like, and then we have to be able to identify what types of transformations are being indicated by the equation of our new function. And so ultimately, there's the graph of g that we were trying to get without even having to plug things in for x.